Good day to you. This is Anagalactic bringing you another science presentation. One of the aspects of the quantum phenomenon is light propagation in free space. The flight of the photon, which I've covered several times in previous lectures. But we are in the synthetic stage. You just can't get a grip on why you cannot get the answer. This has happened before. It's actually a repetitive cycle in science. We are now at the stage where we need to produce a Copernicus, a Kepler, and a Newton. At the very least, we need another Einstein. That has been said out loud. Currently, today, we have thousands of Einsteins. The problem is, it's Einstein. This is linear logic, making its progress, one success after another. And you keep going, and it bifurcates, it forks. And you would think that by knowing what the two realities are, that we now have the golden road. The split to two realities cannot be sustained under linear logic, because now you always have to be on both paths, because they're both real, but they contradict each other. They can't both be real, and yet they are. It's the split of our linear logic system into a different logic system. That is called quantum mechanics. That's called also the wave-particle duality. So quantum mechanics is a restatement of the phenomenological bifurcation point. I want you to know that every time you see the sine wave, what you're seeing is a linearized circular function. And you measure the difference between the crests. And that's the wavelength, crest to crest, which you could consider one wave, because all the crest to crest measurements are the same. There's no such thing as a sine wave. Every time you see a sine wave, you're seeing half of the circle. It's a closed line. It doesn't have plus and minus valence. The circle does not use linear numbers. So that really is the bifurcation point. It's a numeric split that you're trying to measure a thing which is not a thing. And that is a paradoxical thing to say. But that's the nature of the measurement problem. It's the cause of superposition and the manifestation of what is called entanglement. We're looking for a relationship that has not been discovered yet. There is such a thing as a mathematical relationship. We're trying to quantify that which has no quantity. There is a quantity, but it cannot be measured such as to fit it into any geometrical framework. In other words, there is a mathematical discrepancy, Bell's inequality, to a numeric discrepancy. It's not quantifiable. It's only localizable. Bell's inequality that establishes a basis for the quantum paradox. When two particles are coordinated, they're coordinated in another dimension, a non-numeric dimension, a transspatial, transtemporal dimension, something that is outside the realm of classical physics. De Broglie introduced a pilot wave theory which attempted to reconcile the difference between the particle and the circle. And we're going to say circle now. It's a difference between a particle position. They define each other. That's very important to realize, that when you're taking a measurement on a particle, you're assuming that it has a position. And if you're measuring that particle when it's in its state that it has no position, then you, by definition, cannot measure it. But that is another way to state the paradox. For instance, the Schrödinger wave equation is a mechanical predictive equation which allows a scientist to take a measurement on state A and then a second measurement, two different particles, or it could be the same particle after a lapse of time. Those would be to measure two events. for that one particle. So you could either measure two events in a particle state transition, or you can try to measure what happens between them. If it's the same particle, you're trying to measure the separation in event state. But if it's two different particles, you're trying to measure the difference in position state, that is, the distance between them. Now, when you combine those, you get the most advanced modern form of experimentation yet tried by man. One of the most difficult experiments ever performed, and it's been done more than once over the past few decades, in order to test Bell's inequality, because Bell's inequality predicts mathematically in a testable way. You can test to see if this relation holds, and the relation predicts one of two outcomes to your measurement, whereby if you make a certain set of measurements, it confirms Bell's inequality. But if you don't get those measurements, it contradicts Bell's inequality. This is exactly what is needed. An explicit test to show if unreality exists. It's a test for impossibility. It's a test for something that either goes outside your system and you're never going to get it, or it's something within the system, and that would reflect on those who have speculated on what's happening. So it's a test of theory. It's a test of the theory of quantum mechanics. What is it? And what it's attempting to correlate are two states, and the inequality is dependent on what you get from the second state measurement. And these are, of course, in sequence. There's two measurements that have to be correlated. And the way this is executed is by putting two particles into a coordinated state. This would be the entangled state. The entangled state is exactly what we don't understand, is how two particles can be coordinated at distance, because it seems to violate special relativity if that were true. So the test is to see if it's true. Einstein said about this phenomenon that, first of all, it certainly looks like it's true that there is something outside the system. That is, there is something impossible happening. Then that would indict the measurement system. Because according to science, the impossible cannot happen. That's the definition of being impossible. And if your existing system of measurement dictates already to you in your mind what is possible and what is not possible, then if what is not possible happens and you can measure it, very difficult to do. Let's drill down. I don't want to leave that sentence unfinished, but what are we talking about here? You see, this is the problem, is that we don't know what we're talking about. So I don't want to come across as just one more person who doesn't know what he's talking about, but literally, we're trying to talk rationally about something that is irrational. So what we're trying to do is discover exactly where it becomes irrational. What is irrational? Well, that's very difficult to say what it is. So Bell's inequality gives us a handle on being able at least to say, in better terms, what in the world is so irrational going on. It's this, that when you coordinate two particles, they're now in the same event state. So the two particles are connected by event. They're the same event. So that if you change one of the particles, you're changing the whole event. Well, that transcends relativistic separation. Here's why. Once you separate the particles spatially, according to special relativity, there's an event gap that's directly correlative with the distance gap. Whenever you have linear distance, you have a time separation. It's a smaller unit the way we think of units, but it's still there. It's a very tiny separation in time. That anything that happens here cannot be simultaneous with what happens here. But if they are simultaneous, then your Einstein needs to be reinterpreted, because special relativity no longer holds. And Einstein's relationship that he established between distance and time which is a direct relationship, has nothing to do with calculus. It's that this much spatial separation is this much event separation. And if you translated the scale, the distance separation is equal to the event separation. Now, they're two different data types, and they're apples and oranges. That's the clue. That's the clue, is that when you separate two particles, you're not separating them in event space. They're still exact. They don't know that they're that far apart. The way that's been misinterpreted is to say that that is paradoxical, that that is a violation of special relativity. You don't, that is not a necessary conclusion. It's not to say that Einstein's relativity is being violated. How would it be being violated? Do you know? It's simply this. Time equals space. Einstein drew a direct correlation between time and space. That time separation is linear. That is the basis of the Einstein field equation. The basis of space-time is that time is linear in the same way that spatial separation is linear. What we need to face now is that is the most excellent and likely candidate for the irrationality. Because ask yourself this question and be honest. Can you define time? Do you know what time is? Do you know how to measure it? Do you know how it is measured? Do you know how Einstein felt that he could get away with equating time and space? It's considered to be proved now, as I'm sure you're well aware. It's the basis of science now. It took over as the basis of physical science. That space-time is considered to be the Bible. This is the voice of God himself speaking. I will speak in these terms if I want to. And if you don't like my terminology, you're invited to come up with a better approach. But I'm going to take the approach that shocks you back into the shock that was experienced when science had to face relativity. Nobody liked it. Nobody trusted it. That is the bifurcation point. It's the bifurcation between time and space. Space used to have no qualities. The most of a quality that space was ever attributed in an attempt to characterize space in some way, first of all, it was noticed that that's the medium of propagation of light. Space could actually be defined that way if one chose to do so. We've already chosen how we define space. It's with a three-line grid system. That's the only way we can see space. That's the definition of the basis of science, is that it's a three-line grid. Well, you know already from having listened to my lecture series that that's impossible, that a three-line grid could possibly be the right system. It's definitely wrong. It's not wrong for technology. Technology is what is based on linear logic. A linear algebra works perfectly for earth sciences. And so we've considered it to be absolutely reliable for everything. And thus space-time has come to dominate science so that it has rebased our conception of space itself, such that time is part of space. That's only partially true. And this is the most difficult negotiation that the collective scientific mind has ever faced. And so far, we've failed. If it's true that we failed, and that we actually cannot get the answer to the quantum paradox, then we're finished as a race. Our purpose is ended as scientists, as a race of scientists. Humanity can be considered a race of something that humans do, but nobody yet has figured out what the fuck humans do. What purpose do humans serve in the universe? There's not even a guess at that. Everyone hates that topic because if you're trying to get a reason for why humans exist at all, to do anything, present or future, or to somehow sum up what we've done in the past, just to give some characterization of what the fuck humans do. It makes, why do we have technology? Why are we doing what we're doing? Well, the only way to get the answer to that is to return to the blueprint and admit there's a designer. And nobody can do that because they'd lose their minds. They just go insane because everybody hates God. That's the definition of the human race. No, none of the animals hate God. Rattlesnakes, vipers, scorpions, they don't hate God. They just do what they're programmed to do and then die. Not humans, Daddy-o. Humans, whatever humans do, it's to defy God and disprove God and to hate the idea of intelligence above their own. Humans do not like to think that there are intelligences beyond their own. So that's why we really don't have great incentive to solve the quantum paradox. And we can see that we don't have sufficient incentive to solve it because nobody can solve it. It is solvable. I've solved it. It's easily solved, but only if you have clear vision. It's a law of the universe that I must have discovered because I've never heard anybody say this. In order to get the answers that science actually seeks for humans, for humanity, what is the meaning of existence, of reality? Why are there humans? Why is there an ecology? You have to go into the philosophy room to talk about these things. Why? Because it has to do with superintelligence. It's the basis of science. It's the basis of consciousness. It's the basis of rational thought. You would not be thinking unless there were an entity that had programmed you to think. People are talking about quantum phenomenon now in terms of time dilation, time contraction, time travel, simultaneity. I hear it all the time. Down at the coffee shop, I engage in 2 and 3 hour conversations now, every week, with some loop nut who believes that he's smarter than everyone else, because you have to be to see this. And if you're that smart, then you're allowed to pontificate and build in all directions and just give it to some victim like me to just absorb because you're so fucking smart. Well, I have heard some pretty good stuff come from this direction. It's the idea that these thoughts are occurring, that are synthetic, they're inductive, they're super something. You're trying to expand your ability to comprehend, to see, to understand, to explain, to know, to appreciate. What for? Well, I don't know about you, but I could not exist without gratitude. I hope that helps you orient to what we're trying to do. We were staring at the answer the whole time. Fractions, yes, very simple. Fractions are not linear numbers because the multiplicative divisional number system is a closed number system. Did you ever hear any of your professors say that? No. No professor has ever said it, unless you include me as a professor, in which case exactly and only one professor has ever stated the obvious about our mathematical system, that we use 2 of them. We're currently using 2 number systems. One of them is the additive number system that is limited to linear space because it only has one operator, add. So that has an identity number, which we call 0. And the index for the number system for the line is 1. And that is the full definition of linear mathematics. That is not what we are taught in school. And so it's time to correct our number system. And if you don't like the fact that the person who is reteaching you the true number system looks like me in the sense of having no credentials, no awards, no titles, no connectivity, no money, no networking, no professor to support me, no group behind me, no research group, no grants, no attention, nothing. This comes out of the desert. This is just a voice in the wilderness telling you what none of the other professors can tell you because they don't know. So here's where we start, and then we're going to close this off at 40 minutes, and in the next presentation, which will be later today, I'm going to show you the geometry and mathematics of time to show you that there is a parallel universe. And then I'm going to blow your mind, and you're going to have your mind blown up so that you won't have a mind anymore, because you're going to enter a new dimension that's bigger than the universe. Your universe is going to become infinitely bigger, but paradoxically perhaps, and this could be the actual final statement of the paradox in existential terms, that when you finally see the universe to become what would be only the second human being after me, I'm the first person to see this. And I'm sorry, whatever you think about that, I don't care. I can't afford to care what you think about it. Or feel is the right word. The number system that we've been using is actually two number systems that we've confused. And it's because we're using two objects and don't realize it. So we've been using the line. That's why it's called linear algebra. It's because it's based on the line. Because we use linear numbers. Everything is linear. That means 0 to 1, 1 to 2, 2 to 3. That's linear. Single component numbers. We also use the multiplicative operator, which is not linear. And the reason you know that it's not linear is when you look at the inverse. Because addition, as you well know, has an inverse operator called subtraction. So that's very interesting that addition has an inverse called subtraction. Well, multiplication also has an inverse, but it's not polar inverse. It's not linear inverse. The inverse of multiplication we call division. Don't call it that anymore, because it's confusing to use that word. The word division is a stupid word. It's a dumb shit word. And here's why. You're not dividing anything. What you're doing is demultiplying. When you add, you know that you can invert that and subtract and get back to where you started. That's called the additive identity relation. That if you add 2 to 0, you get to 2. But if you subtract 2 from 2, you get back to 0. So 2 and negative 2 are linearly reciprocal. So reciprocal. I'm using the word right, so adjust. +1 and -1 are linearly reciprocal because they cancel to the identity on the operator. 1 and -1 on the line are reciprocal because they add to 0. 1/2 and 2/1 are inverse because they multiply to 1. Do you see the connection there? These multiply to 1. These add to 0. These multiply to 1 and divide to 1, in and out of 1, in and out of 1, in and out of 1. But the linear numbers go in and out of 0, in and out of 0, not 1, 0. It's the difference between a zero-based number system and a unity-based number system. No man is ready for that. I'm extraordinarily stabilized. It's extremely important for a man in my station, the greatest scientist who ever lived, by definition, perhaps even the wisest man. It's dangerous. If you live alone, you start thinking this when you wake up. You start to go review your troops. There aren't any, okay? There are no troops. It's not like there's a big crowd waiting for me every day. There he is! He's going to teach us about the universe. He's the only man who can do it. No, you know what happens to that man? Crucifixion. We'll be right back.